Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. My returning guest is Scott Anderson. He's a science journalist and an author. His book is The Psychobiotic Revolution. It's a book that explains the revolutionary new science of psychobiotics and the discovery that your brain health and mental state actually is correlated to the state of your microbiome. Very, very interesting. I wanted to talk to Scott today about how intermittent fasting and fasting affects the microbiome, because I feel like it's a hole in the knowledge of the microbiome and people. And I know it's a new field. There are a lot of holes, but anyway, welcome, Scott, and thanks for coming.
Thank you. It's good to be here.
Yeah, tell listeners a bit about your background and, some of the interesting stuff you've covered, and then we'll talk about the book and we'll talk about intermittent fasting.
Sure. I came out to Ohio to work on a laboratory out here for racehorses. And what we found was that racehorses had ulcers, and the ulcers were in their colon. People knew that horses had gastric ulcers, but nobody believed that they had colonic ulcers. And we did some research. We were doing autopsies, necropsies on these horses. And we found out that they did have colonic ulcers, and those that did also were poor doers. Those were horses that did not race well, did not run well. They had issues, and among those issues, we try not to personify or to anthropomorphize too much, but these horses looked basically depressed, and some of them looked anxious. There were some horses that were very skittish, and they were all the same horses that had problems with their gut. And so we started to think that there was a connection between the gut and the brain, and I looked around and found that indeed there was some research going on in Ireland with John Cryan and Ted Dinan. And they were doing this research with mice mostly, and they used germ-free mice, and they found that mice that didn't have any bacteria behaved differently. And everybody was a little bit concerned about that. It's like, why would bacteria in the gut have anything to do with the brain? And so they started to do this research, and they came up with a term called psychobiotic. And psychobiotic, they meant to refer to bacteria that can improve your mood. And I realized that this was exactly on point with what we were doing with the horses. And so I called them up and we talked, and we agreed that we should do a book about this. And thus was born the Psychobiotic Revolution.
Do you think that certain bacteria enhance our mood because then it makes us more likely to not only, let's say, tolerate the bacteria, but produce the, short-chain fatty acids and sugars or whatever they need as food source? You think it's, that's the reason? Like taking someone out to dinner, a nice dinner and a movie, and getting them, in a happy mood so they want to hang out with you.
Yeah, kind of like that. What's going on is on several different tracks. So there are at least 3 different ways, and there's probably many other ways that bacteria communicate with us. And when they do, they can tell us certain things about what's going on in the gut, but it's a little vague. It's hard for us to understand it exactly. And we interpret this in different ways. And one of the ways is if we've got food poisoning, for instance, you're aware of what that feels like. Anxiety peaks immediately. bacteria are able to produce something called lipopolysaccharide. And these are pathogenic bacteria. And within minutes, you'll start to feel anxious and you'll start looking for a bathroom. So we know that that's one end of the spectrum. That's kind of wild end of it. But that's one way that bacteria can make their presence known to you. But what's striking is that bacteria can produce neurotransmitters. They can produce dopamine and serotonin, which are two of the primary neurotransmitters involved with anti-anxiety and antidepressants. So both of these things, these neurotransmitters and others, are able to communicate directly with the brain via the vagus nerve, which winds its way up through your body and goes past the stomach and on up to your brain. So there's a direct communication that way. There's another communication through hormones. There's something called the HPA axis, the hypothalamus pituitary adrenal axis. And that's involved with the flight or fight response. And that's the sort of thing that produces cortisol, which is in humans is a good indicator of stress. And so that's another way that the bacteria can actually affect the hypothalamus, which then in turn can produce these cortisol and other corticosteroids that can affect your mood. And then the third way is through the immune system. And this may be one of the more important ones because what happens with pathogens is that they can trigger an immune reaction. They can also actually get right through the lining of the gut itself. And when that happens, they get into the bloodstream. And then the heart merrily pumps them to every single organ in our body. And we now think that a large percentage, maybe almost all, of chronic diseases are starting in the gut. And that's an astonishing understanding that kind of makes you wonder how we got into this situation and why we let microbes have such a big impact on us. But it's not, the reality is that we share the world with microbes. They were here first. And
right. Why would most pathologies start in the gut? Why would you say that?
Because it seems that what's happening is that if you get a leaky gut, and that's when your gut is more permeable than normal. The gut always has a sort of a leakiness to it in the sense that it's able to absorb the nutrients. So the reason that we eat is to get nutrients, and that means it has to absorb something, but it has to be absorbent, and at the same time, it has to keep bacteria out. So it lets nutrients through and bacteria out. And that's a tricky task, and sometimes it fails. And it fails if you have pathogens who can cut a hole big enough that bacteria can get in and get into the bloodstream.
It's like in a house, like I have the shower and the toilet and the sink and all that. They're fine and they're combined pipes and space. But if they overflow, they ruin the rest of the house. And the rest of the house doesn't need that, So it sounds like that with the digestive tract.
Yeah,
so
I'll go.
Stomach acids need to stay contained. All that stuff needs to be, and when it's not contained, that's what it causes havoc when it leaks out.
I'll go with that metaphor. And the idea is that we've got all these bacteria that are in our gut. They're supposed to stay in our gut. And no matter how good the bacteria are, no matter how good they are for your mood, they're not good once they get in your bloodstream. So we want to keep them all in the gut. And when they get out of the gut, they can give rise to infection. And then the immune system goes after them. And then if it continues, you can get inflammation, which is where the immune system kind of goes onto high alert. And if that happens over a long enough period of time, now you've got chronic inflammation. And given enough time, it can wear down the defenses of your various organs. So we think now that things like Parkinson's and Alzheimer's, heart disease, many other diseases, in particular things like obesity and diabetes, type 2 diabetes, are most likely starting in the gut. And they're starting exactly with that mechanism of a leaky gut that's allowing bacteria to infiltrate the rest of your body, or as you would put it, overflow the toilets into the rest of the house.
That makes sense. Well, I wanted to jump to the topic of intermittent fasting and the microbiome, but this is becoming more and more interesting the more we talk about it. Let's spend a little bit more time. What are some of the, the connections that people can use to tell them, all right, something's going on, or I should change this, I should not do that, or, medically or clinically, what kind of intervention does this suggest?
Yeah, insofar as trying to actually understand what's going on in your body, It can be tricky because the bacteria are not talking to you in human language. They're just basically sending some very crude kinds of notions about how, yeah, things are good or things are not good. There is something called irritable bowel syndrome, and it's something that a lot of people suffer from. And like many of these other kinds of gut diseases, they're hard to diagnose. And irritable bowel syndrome is generally diagnosed by saying, okay, well, it's not this, it's not this, it's not that. So we have nothing to show that it's anything, therefore it's IBS. That's not a very good way to do things. We just don't have a very good way to detect some of these issues. And that's something that has to change. There are becoming some better methods of detecting things like IBS. There are other things too, like IBD, which is inflammatory bowel disease, which is actually much easier to detect and also a bit more severe, and you can end up having your colon just actually taken out if that gets bad enough with enough ulceration. And so there are a lot of these gut diseases that are telling you that things are unbalanced in your gut. But there can be more subtle things. And one of those subtle things is I'm depressed and I have no good reason to explain it. If you're bereaved and you've just lost somebody or you've lost your job or whatever, there are lots of good reasons to be depressed, good reasons, in the sense that they're explainable. And then there's depression that seems to be coming from out of nowhere. You don't have a good reason for what's going on. And that's when you might want to look to your gut. You might want to see maybe things are going on down there. If you go to a psychiatrist and have him look at you, one of the things you might ask the psychiatrist is, can you give me a little insight into my gut? I'd like you to look there first, because if you do, you might find that that is actually a big part of what's causing your depression. So this is a new thing that psychiatry is trying to get used to. It's having a hard time because this is brand new stuff that is not taught in the schools. I write for Psychology Today, and I'm constantly aware of how a lot of psychiatrists are shocked to hear about bacteria having anything to do with the brain, which is strange because the gut-brain axis is not exactly new anymore. It's been around for at least 10 years. But they're still not getting it in school, and it's still not a part of most of the psychiatrist arsenals for looking at depression or anxiety.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
So, I mean, how would we discern when we feel anxious, when we feel depressed, when we feel these ways? I don't know, what kind of a test could you think about that would tell someone it's coming from the gut versus not from the gut? There's some other reason for it.
Yeah, there's some things that you can see pretty easily. Like I said, IBS is a little bit tricky because it's one of those things that's like, well, it's nothing else, so it must be IBS. But there are some tests. There's a breath test that you can take for IBS. It'll show that you've got some issues, and that's actually one of the better ones for detecting. It's basically looking at some specific gases that are generated by IBS. So that's one thing you can do. The other thing you can do, and I totally recommend this, is to try things. Try changing your diet and see if it makes a difference. It's astonishing what can happen to people if they just start eating more vegetables, and those vegetables are vegetables that are high in fiber. And those include things like asparagus and artichokes, onions, things like that. And in the book, The Psychobiotic Revolution, we give a big rundown on which vegetables are the highest in fiber and which ones you might want to look at. And if you do that, and if you start taking notes on it, because these things can take a few days to kick in, so you might want to keep notes. It's kind of hard to remember all of this. Then you might find that you're feeling better and that it's based on changing your diet. As simple as that. Or it could be because you've started taking probiotics, either as a supplement or as a ferment. One of the things that we recommend in the book is eating fermented food. And that includes things like yogurt, sauerkraut, kimchi, kefir. Those are all things that are highly recommended because they come with some built-in bacteria. And if you get the live version of all of these things, don't get the canned, pasteurized sauerkraut. That won't help. But you get the live sauerkraut, the stuff that's in the refrigerator section at your store, and see how that helps. And start slow. These things are powerful, and that you can get gas from it as your bacteria start to perk up. As the good bacteria start to perk up, they will produce gas. But it's a short-term thing that will taper off as other bacteria come up and start to utilize that gas. So it's something that you can do. I think that for my own case, because I had IBS, I tried every probiotic on the market. None of them worked. And then I tried a prebiotic, and it did. A prebiotic is food for the probiotics. It's food for your good bacteria. It's basically fiber. And the one that I tried was galacto-oligosaccharide, which is a mouthful. They call it GOS. And that cured my IBS. I'd had it for my entire life, and they cured it. And it cured it in about a week. And it was dramatic. It wasn't something where I wondered what had happened. I knew exactly what had happened.
So you took this, and this was a food for the bacteria that helped to resolve your gut. And in 1 week.
In 1 week.
How long were you suffering with this? What was the suffering life, if you don't mind?
Since I was born with it. And my mother tried to take me back to the doctor saying, this baby's coming out of both ends. And so I've had it all my life, and it's made me miserable. And this was 10 years ago now, I'd say, about that I started taking this galacto-oligosaccharide. And since then, I've started taking other prebiotics as well. And in fact, I'm manufacturing one myself right now called Clarity. We're starting to get into that business using all the information that we found. We realized there was a completely unmet need for this kind of a blend of prebiotics.
I hope this doesn't get personal, but it's galacto-oligosaccharide in breast.
Is it what?
Is it in breast milk? Where does it come from? This
no, it actually comes from bacteria. So they have bacteria that digest milk and produces this galacto-oligosaccharide. There is actually something called human milk oligosaccharides, HMOs, and those do come from breast milk, human breast milk too. So, and I'm not sure exactly what the manufacturing process is on that, because that's not coming from women. It's coming from some other bacteria that's creating it. And so I'm not positive of how that's done. But galacto-oligosaccharide is bacteria that is fermenting milk and producing GOS, this galacto-oligosaccharide. And that is a prebiotic that feeds specific bacteria in your gut that are the good guys. It feeds the psychobiotics. It feeds the bacteria that make you feel better. And those bacteria are producing something called butyrate. And this is a central part of the entire story. And when we get back to intermittent fasting, you'll see that that's a big part of the story there too. And butyrate is a molecule that's produced by bacteria that is both the nutrient and a healing agent for the cells lining the gut. And so it's like ambrosia for the gut. It is something that if you don't have it, that's when you will get a leaky gut. And if you do have it, you will have great bowel movements. Everything will be wonderful in your life.
How was this oligosaccharide discovered? How did you know to take it? We looked at it first.
The oligosaccharides have been around for a while, for a long time. One of the places that you can get them, there's a fructo-oligosaccharide that comes from chicory root. There are many of these that have been known as prebiotics for a long time. The actual composition of them is kind of fairly recently understood. They are long chains of sugars, and they cannot be digested by humans, but they are digestible by the bacteria. So they make it clear through your gut without being digested and make it all the way to your colon where they can feed the good bacteria down there. And people have known about this for a while.
These compounds are in breast milk. It may not be the exact one, but I remember speaking to people, there are oligosaccharides in breast milk, and humans can't digest them. And they encourage the right bacteria to take up residence in the baby's digestive tract.
That's exactly right. They make a large part of human breast milk. And so they're not meant for the baby. They're meant for the baby's bacteria. They cannot be digested for the baby. So the breast milk actually has bacteria that is actually curated from the mother's gut. So there are cells called dendritic cells and macrophages and other parts of the immune system that go into the gut and find the bacteria that are the good bacteria and carry them through the lymph system to the milk ducts. And so what the mother is actually producing in breast milk is both bacteria and the food for the bacteria in the form of these prebiotic oligosaccharides. So both of those are in the breast milk because it's really important to get the baby a good start on its bacteria, on its gut microbiota. And if you don't, the baby will be very sick. And that's probably what happened to me too. At some point, something got wrong and something, went wrong with my gut early on. And it can set you up for a lifetime of unpleasantness. This is why we recommend that babies get breast milk, is that it's a great way to kickstart the gut microbiota in the baby.
Okay. Well, it's excellent. That's a fascinating story, by the way. Really cool. For now, let's shift a little bit to intermittent fasting. So what's happening when someone fasts, for 12 hours, 24 hours, maybe 2-3 days? There's no food going into them, the liquid. Is the body producing just ketones and other types of fuels that the bacteria switch to and they accommodate, or does it kill certain bacteria that only could eat sugar and change the prevalence of certain kinds of bacteria and change over the gut? Like, what happens?
You got it. I mean, it's not, the ketones are not, to my knowledge, are not involved. Ketones are alternative fuel for your body when you don't have any carbohydrates. So if you're not eating carbohydrates, then your body can convert fat in your body to the ketones, and that's an alternative fuel. So we're designed to run on both glucose and ketones. Those are two different fuels. It turns out that the brain can operate better. Some people's brains can operate better on ketones than they can on glucose. And so kids who have refractory epilepsy, they can't be cured any other way. If you put them on a keto diet, they will stop having seizures. So we know that the brain can operate, for those kids, operates better on ketones than it does on glucose. But as far as your gut microbes are concerned, what seems to be happening, and the studies are coming through, and I'll have to say that a lot of these studies started with mice, and so we know a lot more about mice than we do about people. So we'll just start a little bit with what we know in mice, and that is that if you start to fast, if you put these mice on fasting diets where they get, say, 16 hours a day or so of not eating, and it can go up, and we can talk about fasting that's a whole day fasting or 2-day fasting, but for most intermittent fasting, you try to narrow your window of eating to about 8 hours a day. And there are lots of variations on this theme, but that's the basic idea. And when you do that, you're still feeding your bacteria, but you're giving them this time, this period where you're not feeding them. And during that period of time, they do get reorganized. And apparently what's happening is that some pathogens are dying off. And the bacteria that are benefiting from this are including Lactospiraceae and a few others, Akkermansia. I'll just kind of give you a hint of some of them. Akkermansia muciniphilus, which is one that is kind of new to the world and is now starting to be available, by the way, as a probiotic. So you might want to look at that. Faecalibacteria prausnitzii. These are really big mouthfuls, but remember prausnitzii.
One question.
Yeah.
Akkermansia. So now, what are the role of these various these bacteria you're talking about? If you don't mind stepping through it,
No, I don't.
Muciniphilus, you said.
Yeah, Akkermansia muciniphilus is kind of an interesting one because it's fairly new to the world, prebiotics and probiotics. But it is a probiotic that the name muciniphilus means that it loves mucin, which means it's a snot lover. And so it actually ties into the mucus that lines your entire gut, and it gets in there. And the way that it works, apparently, is that it causes your intestinal lining to create more mucus to feed it. And in the process of doing that, it helps to insulate itself better against pathogens. So it's not clear that Akkermansia is always good. For some people who don't have a lot of mucus, it can actually damage the gut. But for most people, it makes the gut actually a better environment for preventing attacks by pathogens. So that's Akkermansia. Then there's prausnitzii, and I'll kind of go through these quickly because they all do the same. These are all Clostridia bacteria. Now we
not difficile, not Clostridia difficile, right?
Not difficile, and because Clostridia has a bad name, and it's because of Clostridia difficile. And
I know,
yeah, and that's really bad. I mean, 30,000 people a year die from Clostridia infections. They get these infections because they go to the hospital and they get antibiotics, and antibiotics kill off all of the bacteria willy-nilly. They don't really pick on the bad guys. They just kill off all bacteria everywhere. We're not good with this. We don't understand that in the act of killing the bad bacteria, we're also killing the good bacteria. And that's because we don't really understand the idea that there are good bacteria. And so we kill off everything with the exception of a few bacteria that can form a shell around themselves. And that's Clostridia difficile. It can form a shell. So it's the last man standing. Well, it's not necessarily bad. It's in your gut normally. But when it's the only one there, it takes over and it becomes a bully and just runs roughshod over your gut, and it will kill people. And so what people do right now, the best treatment for C. diff infection is a fecal transplant, where you take the fecal matter from somebody who doesn't have C. diff and you transplant it into this person using an enema. You transplant it into the patient, and they can be cured of C. diff infections within minutes. And by the way, their mood improves. So this is another example of psychobiotic action, is that when you get these transplants, you want to be looking at who is the donor. If the donor is depressed, you might end up being depressed. If the donor is happy, you might end up being happy. If the donor is fat, you could end up being fat. So there's a lot of things that get transmitted through the aegis of a fecal transplant. So you want to get the right donor. It's sort of a gruesome topic, but it's really super important because it's a big part of the research that shows you not just that things are correlated, but that things are causal. We can actually prove that things cause other things because you can do a transplant and the only thing that's changing is you've moved bacteria into this gut. And as a consequence, things have been happening. So you no longer need to say these are correlative. You can say now that these are causal. So we now know that certain bacteria do cause a depression and anxiety. So it's no longer just a guessing game.
A lot of scientists seem to throw their hands up at the complexity, and they talk about what I perceive to be useless metrics like diversity or things like that, and in terms of bacteria. But also from what I understand, if you have bacteria X, Lacromantia, Mucinephilus, in the presence of other bacteria or in the absence of the presence, its metagenomics will change. It's what it produces will change. How it acts will change. And part of this, as I understand, there's a redundancy. No one bacteria can only do this one process, and there's other ones that can, if needed, to make the gut more robust. Presence of each other, it seems like the bacteria change their function sometimes dramatically.
You're absolutely right. It is something that a lot of people throw their hands up. It's complicated. It's super complicated. It is an ecosystem that's in your gut. And that ecosystem, like all ecosystems, benefits from diversity. No matter what certain TV pundits might tell you, diversity is a good thing for an ecosystem point of view. And it has to do with this functional redundancy. It has to do with the fact that if you have a wide diversity of bacteria, and bacteria can swap genes, so they can pick up genes from other bacteria, they can pick up genes from all over the place, it's kind of a mess. It makes it hard to even identify bacteria because you identify bacteria by their genes, but if they're swapping genes, what does that really mean? So it becomes really tricky. There's nobody who says this is simple, but it is intriguing to see that diversity is, at least to some extent, an indicator of health. But we're also seeing that maybe a better indicator of health is certain specific bacteria. And in particular, it's things from the Clostridia group that includes things like Lactospiraceae and Lactobacillus and Bifidobacter. These are specific bacteria that produce butyrate. And that seems to be, if anything, the number one most important thing about gut bacteria is if you're producing plenty of butyrate, then you're in good shape. And if you're not, then you're in bad shape. So butyrate seems to be, and there are other, it's called a short chain fatty acid. There are others. There's acetate and propionate. But butyrate seems to be at the top, the good molecules that you want in your gut. So that's one way to look at whether you've got a healthy gut or not, is whether you're producing butyrate. And if you have more butyrate producing species, and intermittent fasting does that, intermittent fasting improves the ratio of butyrate producing bacteria to non-butyrate producing bacteria. And that's what we think is providing most of the health impact, a lot of the health impact of intermittent fasting. There are other aspects to it, but that's at least one of the aspects that's important.
Again, going back to the intermittent fasting, I don't know, has there been any scientific experimentation where before, during, and after a fast, let's say for 24 hours or 48 hours, has a group of people had their oral or fecal microbiomes sampled to see what the changes are? And does the gut rebound and go back to the previous state once they start eating?
Yes. And a lot of those studies have been done with people going through Ramadan. So thank goodness for religions that have people fast on occasion, because otherwise it's not easy to get people to do it. And so Ramadan is one of those things where they can look at it and they see that after a period of fasting that it does favor butyrate producing bacteria, and that has an impact also on your immune system. Your immune system can produce things that are going to be pretty much, fighting against the bacteria or giving the bacteria a pass. If you can imagine how difficult this problem is, because your gut microbes are a big part of you. It's like an organ, and it's a very important part of you. You can't live without it. Really, you need it to protect yourself against the pathogen. The first line of defense against pathogens is not your immune system, but your own gut bacteria that fight against it better than you can. But if it gets past that, then it goes to the immune system. And after Ramadan, after certain periods of fasting in people, we see both an increase in the amount of bacteria producing butyrate, but also an increase in what are called regulatory T cells, which actually act to tamp down the immune reaction. So it's a way of improving the gut lining through the production of butyrate, but also by toning down the immune reaction so that the immune system gives the good bacteria a pass and says, okay, I'm not going to attack you guys.
Has anyone looked, though, because a lot of fasts or Ramadan or black fasts, either, non-religious ones appear to be predominantly, liquids only, water, say, maybe some electrolytes. Has anyone looked at the differences between those two types of fasts? And again, ones that instead of going for, approximately 12 hours for Ramadan daily, go for 24, 72 hours, etc.
The only ones that I'm aware of right now are the Ramadan studies and studies that are done specifically with people on intermittent diets. In both cases, what they are showing consistently is that these specific bacteria, Lactospiraceae, Lactobacillus, Prausnitzii, these are all elevated after a fast. And as a consequence, you are better protected from the pathogens and better protected in terms of improving the health of your gut lining and better protected from the point of view of your immune system standing down and letting things, not go nuclear.
Again, a good addition is to look at these other types of fasts, see what happens instead of, like I said,
There are ongoing studies with that, and we will probably start to see some more good information from those. And the studies that I'm seeing are not from extended fasting. They're not from multi-day fasting. So that's something that, if you want to get into 2 or 3 day fasts, that's something that I have not seen good data on yet. I'm not saying it's not out there, but I haven't seen it. And so, I've got my alerts out. And if I hear of anything, I'll let you know. But right now, it's intermittent fasting, Ramadan, and a few other things that are kind of short-term fast, not long-term. So we'll see what happens with that.
Well, also there's Walter Longo, ALTR, the fasting mimicking diet. Be interesting to do another study based on his protocol, which again he calls fasting mimicking. There it would be much easier, I would think, for people to comply, and maybe you can get a cohort to do that, and that might be another very interesting tool.
You're right. And one of the things, Walter is great, and one of the things that is evident from his studies is that people will tolerate this better than they will tolerate a long-term fast. And that's one of the really cool things about intermittent fasting is that a lot of people can handle this. A lot of people can handle an 8-hour window of eating, but very few people are really up for a multi-day fast. And I've done it. I've done it many, many times. And I always feel better after I do it. And I always lose weight after I do it. But I try to do it with my wife and she's like, oh, okay, maybe 1 day, maybe not 2 days. And she just really can't do it. And, she's a nurse. And I think it's harder for her to have the stomach rumbling that entire time. And she's on her feet. She needs the energy. So it's easier for me being a sort of a slug. As a writer, I just sit around here all day. And it's not that hard for me to go on a 2-day fast. So yeah, I think that the beauty of the intermittent fasting is that it's tolerable by a lot more people.
Okay. Yeah, it makes sense. So what, either in psychobiotic realm or in the fasting realm, what additional research and experimentation do you feel like needs to be done? If you had the money and the ability to fund it, what would you fund it? What would you hope to find?
Well, there are a couple of things. One is more research into fecal transplants. The FDA, in its infinite wisdom, has decided that feces is a drug, which is weird.
A drug, so they can regulate it.
Right, and that's what they're doing. And as a consequence, you can't get fecal transplants unless you have C. diff. That's the only indication that they're allowing. And that's too bad because there are many people with many different problems who could very likely be helped with fecal transplants. And so the FDA needs to figure out what is going on there. And they don't consider blood to be a drug, and it's another human product. So I don't understand why they've decided that they need to research this. It is the safest treatment that I've heard, as long as you do it right, as long as you analyze the fecal matter before you put it in, it's been very safe. There's one death after hundreds of thousands of transplants, and that was because somebody did not do the proper checking on the fecal matter. So if they want to do anything, make sure that the fecal matter is free of disease. But other than that, they should get their hands off of it and let people experiment and find out what's going to work. So I would like to see that. There are some people working on oral versions of this, which of course are called capsules.
If it appears to be okay and it's in a capsule and it doesn't smell and all the other stuff, then yeah, I guess people will be more amenable to it. But otherwise,
there's still an ick factor. But if you're sick and you can be helped by it, then yeah, for sure. And people who got C. diff, they don't even hesitate. They're like, yeah, fecal transplant, that sounds disgusting. Give it to me right now.
But I've heard that people's personalities change. The effects are very dramatic. Like what? Why?
Because what's in your gut affects more than what we imagine that it affects. It affects not just the health of your gut, but your mood. It affects your ability to gain weight. It affects the way that your pancreas is working. It affects the inflammation in your body. It's super important to have a good, healthy gut lining. And the way to do that is to have a good, healthy microbiota. So it's, like I say, so many chronic diseases start in the gut. It might be basically all chronic diseases start in the gut. I'm not going to go that far, but it certainly seems that we can point to a number of the top diseases in the world start in the gut. And so we really need to be paying more attention to this for sure. So that's one thing that I would do, is definitely do more work on these fecal transplants, because the things that it can do for you in terms of your health, your mood, your overall body type, all of these things can be changed by getting the right bacteria. It's astonishing. And so that's one thing I would do. The other thing that if I had a lot of money is I'd be working on phages. And phages are, these are bacteriophages that actually live on bacteria, and they kill bacteria. They can kill the bad bacteria.
Genetic material with bacteria too. I've heard that they facilitate like plasmid transfer, either intentionally or unintentionally.
That's correct. And that's probably how bacteria become antibiotic resistant. And antibiotic resistant is by picking up helpful little genes from passing viruses. So a phage is a virus that lives on bacteria, and they are very targeted. So if you have something that eats a specific bacteria like C. difficile, that's the only thing that it will eat, and it will wipe it out. And unlike antibiotics where you might have to take it for days, you just have to give one serving of phages, and they will continue to spread and grow until they've killed all of their host material.
Well, one serving could be like 30 quadrillion of them or something?
Yeah, it can be few as like 100 viruses. I mean, that's really, one serving is really a tiny amount that get through, and then it reproduces itself inside of the bacteria. So it will grow to meet the challenge and will take care of every bacteria in its path. So, and this is something that has been known for 70 years or more. The Russians have been doing it because they did not have, for a while, they had poor access to antibiotics, and it was their version of antibiotics. They've done a lot of research on it, and we are behind the curve on this. And I'm not clear why exactly, because we know we have an antibiotic resistance problem. Phages would conquer that. So that's another thing that I would like to see some more research.
I think, unfortunately, it's money. Even with antibiotic, from what I heard, is very little to no development, because it's not a big money maker like a pill you take forever to,
Yeah, isn't that why we have a government, Richard, is to try and make these things happen, even though there's not money in it?
So I think it's the opposite. I think it's corrupted to where they want you to have to take their stuff forever. There's no incentive to, again, you don't make nearly as much money if you give someone something once that cures them. So don't give them cures them. Give them something that keeps it a little bit better, but they got to stay on it forever.
I definitely understand that. But in terms of making things happen, the government could make this happen if they wanted to. They could just say, look, we're going to do this. And it's a money-losing proposition, but it's taxpayer dollars that are going to take care of it. So, yeah, there are ways to do it. Yeah, but I agree with you that right now the profit motive is not there for antibiotics. And I think, though, that the profit motive might be there for phages, because you might be able to patent those things and they might have a better lifetime.
Does anyone that contemplates the gut ever look at phage activity? Let's return for a second to intermittent fasting, or just characterizing the gut. I never hear anyone that looks at phage activity with leaky gut or with IBS or with fasting, or this might be take away some of the dark matter of the gut and show you really what's going on. Does anyone contemplate it?
There's not much going on in that field. That's why I put it in my wish list for the future, because it seems extremely powerful. And like you say, the only thing that's holding it back is that there doesn't seem to be a good enough profit motive, but people are dying for this. And it seems to me at some point somebody's got to be able to figure out a way to make money off of this, because you could save people's lives. So I remain confused about exactly why we're not doing more phage research.
Okay. I can hear from what you're saying. You're a lot more open-minded, than some scientists. And I guess as a writer, that's what you have the ability to be. Scientist working at a university in a lab, and you depend on NIH funding, even questions that you want to ask, you may not be able to because they're not going to fund that with what's going on.
That's correct. I am a scientist and I do scientific work and I publish scientific articles, but I'm not associated with the university. And as a consequence, I do have a greater freedom. And you're right. As a writer, I'm out there all the time doing all sorts of cross references with different fields. And in fact, this field itself, just psychobiotics, involves gastroenterology, neurology, microbiology. It just goes on and on. Immunology. So you have to be able to, it's very difficult for an immunologist, for instance, to talk to a neurologist about why we should be taking probiotics. They're like, what do you have to say about, what does a neurologist have to say about the immune system? And the neurologist is asking the immune guy, what do you have to say about how the brain works? So it's one of those things that you're almost liberated not being a scientist, because you can cross those fields. And I hear from scientists all the time who've said, oh, I finally get it. Thanks to your article, you've made it clear to me what that other field was trying to say to me. So to bring it down to a human level and to talk to people in a way that hopefully, it's complicated, and I've used a lot of big words in this conversation, but hopefully it's something that people can latch onto from all fields, no matter what your background. Just as a human being or as a scientist, this sort of thing should be able to be discussed, and we should be able to figure out how to make this all work for us in a better way than it is right now.
Yeah, agreed. We're close to being out of time, but I did want to ask you about one more thing. When we eat, who eats first? Who eats second? Is that even a sensible question? And what we eat, what are we doing with the genetic information? Like, let's say I eat a piece of chicken. I know it's been cooked fine, or let's say I eat a raw vegetable. What is my body or my bacteria doing with the genetic information contained within the cells of the thing that I'm eating versus the cell wall versus other non-genetic components? Do you think that there's an assessment and an information gathering? From what I understand, bacteria can actually take some of the genetic material of foods that we eat and incorporate that into their own genes and their own genome. What do you think our human cells are doing, or by using the bacteria, what do you think our body's doing with, again, the genetic component of food?
Well, it's a kind of a weird question, Richard, and I like it. So as far as who's eating first, you have bacteria in your mouth. So it starts right at the very beginning. And before you get much nutritional value out of your food, your mouth bacteria are getting nutritional value. So in a way, they start. But there are bacteria, the bulk of the bacteria in your body is in the colon. And that's where you have like maybe 1.5 pounds or 2 pounds of bacteria. And that gets eaten last. So after everything has been absorbed by you, then the bacteria gets what's left. And that's usually the fiber that we've talked about. The oligosaccharides that are not digestible by us get digested by the bacteria in the colon. As to the DNA that comes into you is broken down by enzymes and broken down by the acids in the gut. So most of that is broken down pretty quickly into the nucleotides. And those nucleotides are useful to you, and you can use them to recreate new DNA. But you're right that bacteria can pick up some of that DNA, and they can pick it up and incorporate it. But bacteria is picking things up from you too. So it's picking up things from your own cells. Your cells are picking up things from bacteria and viruses. So some large percentage of our own DNA is actually viral DNA, and some of it's bacterial DNA too. So there's a lot of gene swapping that goes on that's a little bit disconcerting.
Yeah, if we can endogenize viral DNA, why can we endogenize DNA from the food we eat?
Right. Well, most of it gets broken down. So the fact of the matter is, like, for instance, people are taking collagen and things like that, but all of that's being broken down by your gut into amino acids and into the basic constituents for DNA. It's breaking it down into the nucleotides. And so most of them are broken down, but some of them are getting picked up. Some of them are, almost none of them are being digested by us or being absorbed by us, because if it's real DNA, it's too big to get through the gut lining. The gut lining is pretty specific with that. However, all bets are off if you have a leaky gut. who knows what gets through at that point. Yeah, I'm not too concerned in general with picking up DNA from my chicken, but what I am concerned about is if the immune system conflates a salmonella infection that you had from bad chicken, and it conflates that with the chicken itself. And that may be a cause for a lot of people to be allergic to foods, is that they had a bad experience where bacteria were involved with a specific food. And then after that, their immune system is now on the alert for both bacteria and for what brought it in the first place. So there are some really interesting cross reactions that occur. There's also something called mimicry, which is where every cell, bacterial cells, animal cells, our cells, every cell has these sugars on the outside that are, well, they're major histocompatibility vectors. And these things are ways that cells identify themselves to the rest of the world and to each other. Sometimes those major histocompatibility molecules are confused by the immune system. So something on a bacteria that it doesn't like may look a lot like something in a peanut, and therefore you can become allergic to the peanut because you think it's a bacteria. So there are so many different ways to fool the system. It's really not funny. And we need to be really careful about anybody who says that they know the answer to all of this, because they probably don't. It's really confusing.
Well, very good, Scott. I really appreciate the call. You've been a lot more open and to different ideas than a lot of people I've spoken to. Where's the best way for people to find out more about you? Should they first read your book? Let's say the title there, and then where else can they find info?
The Psychobiotic Revolution is available at Amazon. That's the best way to get it. It's from National Geographic. There are hardcover, softcover, ebooks, whatever you want. It's all there. I highly recommend it because even though it's getting a little bit old now, it's been out for a few years, it's still relevant. And we had the advantage of having some of the smartest scientists in the world vet this thing, and they were so far ahead of their time that the book is still totally relevant. So check it out if you can, and that's where I would recommend you get a start. Everything should go from there. You can also go to see my own site, thepsychobioticrevolution.com.
Okay. Those are the best two places. Excellent. Well, Scott, thank you so much for coming on the podcast, answering these impossible questions.
Thank you, Richard. It's been good talking to you.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.